Hi guys, welcome to New Asset Science Practicals. I'm Mr Beardsall and today we're going to be looking at drawing magnetic field lines. The aim of today's lesson is to draw and record the magnetic field lines around a bar magnet, to describe the Earth's magnetic fields and explain how a compass works, describe and compare magnetic field lines and a magnetic field, and finally suggest improvements to an experiment to observe field lines around a magnet. Okay guys, so we're going to come over here whereby I have my plotting compass available and a bar magnet already set up on top of the outline on this support sheet. Notice that we have the North Pole at the top, and that's indicated by the dot I have here on my bar magnet. I've just doubled the length of the magnet here, which will make no difference to polarity of it. Just whilst I've got it to hand, if we have a look at the plotting compass, so right now this is actually following the Earth's magnetic field. So that arrow at this end here is actually pointing towards the north geographic pole, which would actually be our south magnetic pole, and vice versa for the tail here. But if I introduce that to the magnetic field of this bar magnet, you'll notice that it gets deflected really, really quickly. Okay? So what we're going to do is we're actually going to use this to plot the magnetic field lines around this bar magnet. And I'm going to put this plotting compass, the centre of it, on these dots all the way around. So I'm going to start just here, on this first dot, and what I do is I take my pen and I mark the north and the south points here. And I'm going to continue to do that around you'll notice that the trend here is that at the North Pole, the north seeking part of this plotting compass is pointing away from the North Pole of my bar magnet, because north and north poles will repel, whereas the south end of my plotting compass is going to be attracted to the North Pole of my bar magnet. Hence why if I was to bring it all the way around to the south end of the bar magnet, you'll notice that the north end of the plotting compass is attracted to it. In doing so, we can produce a pattern that would describe the beginnings of a magnetic field. And if we would continue to plot straight ahead, you notice that it would just actually move in a straight line. And the same would be true at the bottom here as well, where we'd have it attracted to the South Pole. And we'd repeat the same for the other side. Whilst I've got lots of plotting compasses to hand, I just wanted to demonstrate what would happen if we were just to lay these plotting compasses out, just to demonstrate the direction of the field. I just want to emphasise the fact that these field lines are travelling from the North Pole to the South Pole. So if I lay these plotting compasses out like this, you'll notice that we start to see a relationship where the plotting compasses are being attracted and repelled to produce this magnetic field pattern here. So here we have a South Pole attracted to the North, North repelled. You know, as far as we're going to get away here, the weaker the field's going to be. Hence why we've got less of an effect here. But you'll notice here that we've got still a field line travelling from north to south, and that's demonstrated nicely by this plotting compass here, where we've got the South Pole here still being attracted to this North Pole, just not as strong as at the pole. So you'll notice here that the strongest field lines can be demonstrated at the poles of the magnet, and I've got another demonstration to show you more visually why that is the case. So a really common scenario is to use iron filings to demonstrate field lines and the strength of the field around a bar magnet. So what I'm going to do is I'm going to take some iron filings in a salt shaker. I'm just going to sprinkle them on the top of the same bar magnet that I had in the middle of my diagram before. And you'll notice where we have the majority of the iron filings collecting will be where the field lines are the strongest. So you actually see some vertical iron filings deposited at either end. So we've still got our north pole and our south pole. Notice that is where we have the majority of our iron filings distributed. These ones are actually pointing vertically up out of the page, because this field is actually three-dimensional. It's not just acting in 2 dimensions on the plane, it's actually coming out of the page and into the desk as well. So it's a three-dimensional field. We don't know where is north and south actually without looking at the magnet in this case, or bringing a plotting compass nearby. The plotting compass tells me here that I do have a north pole this end, but I wouldn't know that just by using the iron filing. So that's the useful, the reason the other demonstration was so useful is to show where north and south are. Here, you can see we've got this field line behaving a bit like a butterfly, where we've got these wings on the side, we've got the antennae at the top and the tail at the bottom, whatever you want to call it. This pattern needs to be reproduced in a test. It's regularly asked about. So having disturbed the field a bit, you'll notice that the field lines are exaggerated, particularly around the poles still. But hopefully you can see what we're demonstrating here with our plotting compasses was this north to south pattern that we're also visualising within the iron filings influenced by the field also. A similar effect can be demonstrated with a simple piece of kit, which is just a bunch of mini magnets, all contained. And even there you can start to see a field being propagated by this magnet. So you can see we've still got a nice straight field from north, from north to south, vertically going upwards, coming to the south end here, and you can see them propagating in this sort of wing patterns, loopy patterns from north to south. Now we don't know the direction based on this, but if we were to introduce our plotting compass, we would see that it very much is a case of north to south. Okay guys, so today we've been drawing magnetic fields. Thank you very much. It's been New Science Practicals. See you soon.